This icy wetland in northeastern Germany is one of many sites in Europe being used to research the hot topic of climate change. Even in early January, scientists are here to measure the exchange of greenhouse gases between plants and soil and the atmosphere. Readings are taken both automatically and by hand.
This is our manual chamber. We want to find out whether they contribute to the exchange of CO2 even under winter conditions.
Even when dormant, the plant is taking in oxygen and putting out carbon dioxide. The researchers are also looking for methane and nitrous oxide, both powerful greenhouse gases.
Of course, there is an exchange of greenhouse gases in the wintertime. The microorganisms in the soil keep transforming organic material. In this case, organic material is transformed into CO2 or methane. And interestingly, if it's really cold and the soil is really frozen, there can be a lot of nitrous oxide released. That's why we need to find out in winter to what extent there's a greenhouse gas exchange in order to give a serious estimation on annual greenhouse gas release in the area.
4 years ago, this site was re-flooded to create a natural wetland area. Jürgen was asked to monitor the subsequent exchange of greenhouse gases. In the first year after flooding, the site contributed to global warming by producing a huge amount of methane. It's a landscape in constant evolution.
The gas fluxes are extremely variable. That's a problem. These gas fluxes are subject to extreme spatial variability. That means at every point in this landscape the gas fluxes vary, and at the same time you have an extreme temporal variability. And this is very difficult to look at. In order to give even a superficial estimation, we need to keep on measuring these gases very frequently.
Another chilly research site, this time in Poland. Scientists here have been working with Jürgen in Germany on a European project to refine measurement techniques.
This is a peat bog. This is a lot of organic matters inside. So the amount of CO2 flux and methane is very high here in this ecosystem, especially when we get temperature above 5 degrees, the vegetation season. So we have these two very, very high level fluxes of CO2 coming in, photosynthesis process, and going out from the ecosystem, which is more or less the soil respiration.
This particular peat bog has been monitored every day for the past 5 years. The data shows that greenhouse gas exchange can vary quite considerably according to temperature and rainfall.
Let's have a look. We knew without these measurements that this ecosystem, the whole area, is a sink of CO2. The only problem, we didn't know numbers. Now we know at least numbers. And that's the very beginning of model creation.
Janusz's latest project is a 40-metre tower deep in the woods. Like many other countries in northern and central Europe, Poland has vast stretches of evergreen forest which need to be monitored in order to build up an inclusive picture.
So Tuczno Forest is the second site in Poland where we measure CO2 fluxes, the exchange between the ecosystem and the atmosphere.
For forests again, the figures depend on many variables. For example, young forests actually emit carbon, while mature forests are carbon sinks or storehouses.
Why we choose this place? First of all, it's very flat and very homogeneous forest. And the age of the forest is 53 years, exactly or very close to the average age of the forest in Poland.
The Polish team, based in the city of Poznan, are now fine-tuning a new instrument due to be deployed in the peat bog and forest.
There are several theories about the transportation of gases in the atmosphere already, and most of these theories are assuming that the gas is moving in the atmosphere in the form of bubbles. And in the case of this system, which is called relaxed steady accumulation, we are just catching separately bubbles which are moving up and separately the bubbles which are going down, transporting the gas.
The aim is to observe the exchange of gases in different ecosystems in even finer detail, ultimately helping us build a much more complete picture of how plants, soil and the atmosphere interact.
We always think that the atmosphere and the landscape we are living in, they are two different things. Actually, this is not really true. If you want to answer for the question, what is the concentration of certain gas in the atmosphere, you must realize what is the exchange of this gas between the atmosphere and the surface.
Drawing conclusions is difficult with so many factors to take into account. Different soil and vegetation will absorb and emit different gases depending on sunlight, temperature, the water table and rainfall.
Right now, this area is a source for methane, and as far as CO2 is concerned, it's a neutral area. The main reason for that is that we don't have the natural vegetation yet. But we expect that once we have that normal mire vegetation like reed or sedges, that we will have a real strong CO2 sink, like in a real mire. And then at the same time, the release of methane will go down.
As models are carefully developed, it becomes clearer how different types of ecosystems and the way they're managed can have an impact on the levels of greenhouse gases in our atmosphere.
If we compare these two fluxes, consumption of CO2 from the atmosphere and emission to the atmosphere, methane, we can certainly, after these 5 years, that's one of the results of our investigation. From the point of view of greenhouse gases as general, these ecosystems help us, help human beings to fight against the increase of greenhouse effect. So protect them. That's our advice.